Good morning to all of you. My name is Mahendra Kumar Shrivas, and I'm going to present my presentation on enhanced simplified symmetric key encryption algorithm. Uh, as far as agenda is concerned, we are going to start the summary of concept because this topic is a little bit technical. So we are going to understand the related topic related to the research work. Then we will discuss the problem domain, what actually the problem we are facing, and why we have conducted that research. And then we are going to discuss on research methods, what methodology we have followed, and then we are going to discuss our results and findings, and a little bit discussion on the reference, and then after followed by conclusion. See, actually, here for any organization, data is very important, and whether it is audio data, video data, or any kind of data that we are using and sharing among businesses, users in our daily life, it is made of a basic thing which is called bits. So in the physical level, all these documents that we use, we refer as a video, audio, or anything else is made of 0 and 1, right? So these are the fundamental things in data, right? So see, when we combine all these bits into the sequence, it makes byte, and then after we are having megabytes, gigabyte, and so on and so forth. So the question is actually how do we share information among each other, right? As we know that, okay, in the form of email, images, office file, videos. So these are nothing. These are just words, sequence of 0 and 1, right? So now what we do, we use a computer network, right? So computer network is basically a interconnection of multiple computer, right? And internet is a global network of computers and internet connected device. So when we share the data, is it really secure? Right? That is a major question that is there in the today's world and today's era. Definitely, it is not secure. There is one group of person called hackers. So what they do actually, while sharing the network, your data into the network, they sniff, they hack, they steal your information, right? The motivation behind that can be anything like taking competitive advantage and taking secret information from one government to another government, right? So what is the solution? How to protect our information in a more precise manner so that confidentiality should be maintained and your secret will be yours, right? So there is one term which is called cryptography, right? So what is that particular one? Basically, it is just take an example. You wanted there is one receiver and one sender, and receiver is sending some information to the sender, and we have to ensure that in between, if somebody or hacker comes into the picture, we cannot stop to stealing the information, right? That is a well-known global fact. But yes, we can make it harder and harder to the hackers that he or she will not understand whatever we are sharing, although he is having the data, right? So that is cryptography. So in the cryptography, what we do, we actually change the data into different format or in a different things. Then after we used to send it to the target audience or recipient. They are having some kind of conversion mechanism where they can get the original message. So that is the whole technology, the whole concept behind that particular one. So we are having two type of cryptography. The first one is symmetric cryptography, and second one is asymmetric key cryptography. So basically, what is the difference? Okay, in asymmetric key cryptography, we use single key for the encryption and the decryption process. So what is the encryption actually? Encryption is what we are having plain text here, right? We are having plain text here, and then what we are doing from the plain text, we are converting that particular one using some encryption algorithm, right? And we are having certain keys. So we convert that particular one so that nobody in between can able to what can able to intercept it, right? Then we used to send this information, this encrypted information to the target audience or to the recipient. Here the recipient is going to decrypt that information using the same key and then going to get the plain text. So that is called symmetric key cryptography. And then we are having public key and private key cryptography. So there is a two different keys which is being used in encryption process and decryption process. As you can see there, we are having original message, and then that original message we are having certain keys we use to encrypt it, right? And after that encrypted message is called ciphertext, right? So this particular one we send it through the network, and then at the receiving end, that encrypted message using a different private key we use to decrypt it. So what happens, suppose that if anybody gets that encrypted data, so he or she cannot able to understand it, right? So that is the main concept behind the whole cryptography stuff. So we are having in this particular research work we have used symmetric key encryption. We are having, say, some of the most famous cryptography algorithms. We are having DES. DES is basically data encryption standard. Then we are having triple DES, right, which is a more advanced form of DES. Then we are having AES, that is advanced standard encryption algorithm, which is basically a standard currently we are following. Then we are having Blowfish, that is another form of symmetric key cryptography algorithm. So basically, what is the similarity in all these one? That is what they are actually. Suppose that you are having a whole file, okay, which is say 1 MB of file. So what these algorithms do, they take small part of the data, right? Generally, it is from 64 to 256 bytes of block. Then they use to encrypt that block, and then they generate. We actually generate the encrypted text, and then we use to send it. At the receiving end, we receive all the particular data or chunk of the data, then we decrypt that particular one, and then we use to get the original message at the receiver end, right? So so these are the related concepts that we have discussed. So what actually the problem was in all those particular algorithms? Actually, it is experimental research work. Okay, so in that particular one, we try to correlate the relationship, and we try to find some problem into that particular one. So we ask ourselves, is it possible to reduce the complexity of the algorithm mathematically? Okay, by manipulating some terms in a more mathematical manner, and still, because you see, security of these algorithms is very important. So do we able to maintain doing that particular one? Can the new encryption algorithm design and implementation to enhance the performance, right? Because we are having small devices and limited resource these devices are having. So can we able to use those these algorithms to those devices? And how efficient is an algorithm using variable key length from 65 byte to 75 bytes of symmetric key techniques for encryption and decryption of data. Can the proposed algorithm be comparable to DES, triple DES, Glowfish and AES? Because that is very convenient and well proven technology. So the new proposed algorithm, is it going to similar to that one or not? Then this is our main algorithm, right? So what we are having, we actually take 64 bytes of key value from the variable key size. It is the key actually can vary from 65 to 75 bytes, and then plain text is strictly 64 bytes. Later on it can be increased, right? But for now it is 64 bytes of plain text. So what we do, actually these two processes are in parallel. So arrange values we are there in the file, and in the key we load into the 64 byte metric form. Then after what we do, we execute column shifting. So there is some shuffling kind of stuff is there, right? And then apply combination function. So once that shuffling is done in key and in plain text, and we use to shuffle it, and then after we combine. After combination, we use some complex algorithm for permutation. So we are having some random permutation function which is being used to mix all those stuff. Then there is a column shifting, then transposition, then perform row mixing. Then after do we have done this process for all of our data? If it is yes, then we are having final cipher text which is encrypted text. So now it is, this text is ready to be sent to our target audience, right? So that is a very secure and very confidential text, right? So this is our encryption process. Once that ciphertext is there, we can send it to anybody, like using network, internet, and in between, if somebody or some hacker is able to take that particular one, they were not able to understand. So that is the whole particular concept behind that. Then in the decryption process, we do the reverse. We are having in encrypted file, right? So we used to take that particular one, then in reverse we use row mixing, then we transpose, then column shifting, permutation function, then execute division into the key will be separate and text will be separate, and then if it is done for all, right, we are finally having plain text. So that is what the whole simplified algorithm, right? So as far as research method is concerned, we have used experimental research design in this particular work, right? So for that particular one, what we have done, we have based on that algorithm, we have created some program, and we have used JDK 7.0, and we have used Java cryptography APIs, which is already available, right? As far as DES is concerned, AES is triple DES, and Glowfish is concerned. And then we created our own. Yes, please.
Mahendra Kumar, sorry for the interruption. You have 2 minutes left.
Yeah.
Kindly conclude, please. We are
Right.
time is over, and you have left 2
Okay.
minutes.
So this is this is some of the effect that we have. These are some variable that we have used, right? So avalanche effect is actually, if we change any one bit, so what is the effect on rest of the ciphertext? So these are the result, right? So as you can see that we are having very small avalanche effect on that particular one, right? And this is our result of encryption time. So as you can see that as compared to other algorithm, encryption time is very less as compared to as compared to other algorithms. So it's very fast. It takes less time. Then we are having decryption time. So relatively decryption time as compared to other one, as you can see in the result, it's very less. Then we are having memory requirement. That's very important, right? So proposed algorithm memory requirement is 5.7, which is very less. So it is going to consume CPU execution time. So key generation, encryption, and decryption, the overall is very less as compared to other one, right? So in this particular one, we have used these kind of reference. For last 2 years, we are doing our research work on that. So as far as the conclusion is concerned, so we are having smallest avalanche effect, which is not good, but yes, it is manageable. Encryption and decryption time is relatively low, which is very good for this new algorithm. Less memory consumption and fastest execution. And basically it is suitable for the devices with low processing and memory capabilities. As far as future work is concerned, we need more complex cryptanalysis to check the authenticity and the security level. Based on that particular one, we can able to adopt that particular. So thank you very much for your time and patience and listening me carefully. If you are having further any questions, please feel free to ask.